Hi, I'm Ronnie. I'm from Egan Mathnasium, and I'm going to be going over a problem today, and hopefully we can solve it together. And let me just move my audio. Sweet. So let's talk about a problem involving some surface area and volume. So let's say my friend from Egan High School got some new paper, stationery with their favorite pictures of their shows and movies on it. So some Marvel characters were on there, some comic characters were on it, and they were so excited to use it. They decided they want to cover one of their cookie jars with it to make it a little bit more decorative and festive. So they needed to find the surface area of the cookie jar so they would know how much they would need to cover. And then they would also need to know how much paper they would need to use. Now, right now, they measured the height of it and they know what the volume is of the cookie jar because it said it on it there. So they know the height is 21 centimeters and that the volume is 2,100 centimeters cubed. Now, we don't know our radius right now, so we need to solve for that first, right? Because that's a key component of finding the surface area is knowing that radius. Now, thankfully, we have two things that we can use to help us with that. So we know our formula for volume is that V, or the volume, equals pi r squared, the radius squared, times the height. Well, we know a few of the numbers for that we can substitute in. So we know that 2,100 is the volume. Pi we can just leave, or let's say, I think that this is going to be 2,100 pi, just to make the numbers a little bit more simple. So now we can say that 2,100 pi is equal to pi times the radius squared, we still don't know that radius, times the height, which we know is 21. So let's begin by solving this. This shouldn't be too hard to do so far because you're just essentially doing some basic division. So you're going to do 2,100 or 2,100 divided by 21, and that you should be able to get 100 pi equals pi r squared. Well, now we also see that pi is on both sides of the equation. That means we can divide it off of both sides and basically it'll cancel out. So now we have 100 equals the radius squared. So that's great. We're almost at finding the radius. So then if we take the square root of both sides, because if you want to undo something that's squared, you take the square root. Same goes for vice versa. If you want to undo a square root, you can square it. So then the square root of 100 is 10 equals the radius. So now we know this number is 10. Now we need to use our formula to find the surface area. So the formula for surface area, if you recall, is surface area equals 2 pi radius times height plus, don't forget that addition, 2 pi r squared. Now let's go through where all this comes from, okay? So the 2 pi r squared, well, we know the area of a circle over here is going to basically be pi r squared. There's two circles on the jar, the top and the bottom. So that means we need to take 2 multiplied by it. Now, where the 2 pi r times the height comes from is because if we were to unravel the cylinder, we'd get a rectangle. So 2 times the radius gives us our diameter of what that looks like, and then we also need the height. And 2 pi r is the same thing for circumference. So circumference times the height gives us what's around the cylinder. Okay, so now let's start plugging in the variables that we know. So surface area, we still don't know that, equals 2 pi, and then we can multiply that by 10 because we know the radius is 10. We know the height is 21, and then we add 2 pi times 10 squared. So now let's go through this and solve. So surface area is 2 times 10 times 21. So that's 420 times pi plus, we already know 10 squared is 100 times 2, that's 200 pi. And then the way we found the 420, well, we know 10 times 21 is 210. Multiply that by 2 is 420. So 420 plus 200 gets us our surface area of being 620 pi. There, you've solved it. It looks great. And that's what you're going to do for there. Now, let's say we knew our surface area and we were trying to find our volume. We could solve it backwards and find it that way as well. So that creates another way that you can work on a problem. Or let's say instead of trying to find the volume of a cylinder, or surface area of a cylinder, we were trying to find it of a cube. Well, we could take that cube and draw it out. And then you could give yourself some numbers such as 5 is the height, and maybe it's not a cube, but it's a rectangular prism. And we know 6 is this width, and the depth is something we don't know. And we could say the volume is 240. So volume is 240. And we were needed to find the depth, and then we needed to also solve for the surface area. We could do that as well. So give a shot at that, or you can also just change around the numbers for a cylinder and call it a day. Both things work. And that is all for today.